All right, so you've been learning Python, and you've probably written some really cool scripts. That's awesome. But now it's time for the next leap, right? We're talking about moving from little scripts that just run and disappear to building real, actual applications that stick around and do useful stuff.
And you know exactly what I'm talking about. You build a cool little game, maybe a simple to-do list app, it's working perfectly. But the second you close that terminal window, poof, it's all gone. Every single high score, every note you typed, it's like it never happened. That right there, that little bit of frustration, is what separates a fleeting script from a real program.
So how do we fix that? How do we give our code a memory so that it can actually remember things from one run to the next? Well, this is pretty much the key to, well, everything when it comes to building useful software.
The answer is a concept called file I/O. And I know it sounds super technical, but it's really not. It just stands for input and output. All it means is we're giving our program permission to read data from a file and to write new data to a file. It's basically a bridge between your code and your computer's hard drive, and it's how we give our program that long-term memory it desperately needs.
And in modern Python, these are the magic words you need to know. This with open statement, this is the golden rule. It's how you tell Python, hey, I want to work with this specific file, and here's what I'm planning to do. Honestly, it's the safest, cleanest, and just plain best way to handle files, because it does a lot of the boring, tricky stuff for you.
Now that third step on the list, auto-close. Why is that such a huge deal? Well, because in the old days, if you forgot to manually close a file, it was a recipe for disaster. You could corrupt your data, lock up the file, cause all sorts of weird errors. The beauty of the with statement is that it's a guarantee. The second you're done, Python cleans up after you and closes that file no matter what. Even if your code hits an error, it's handled. It's just fantastic.
Okay, so when you open a file, you have to give Python a heads up about your intentions. Using mode W for write is like grabbing a totally blank sheet of paper. Whatever was there before, gone. It gets completely overwritten. But mode A for append, that's different. That's like picking up the paper and just adding a new paragraph at the very end. You gotta know which one you want, because choosing wrong can be, well, a bad day.
And this leads us to a fundamental truth of programming. Things are gonna go wrong. It's inevitable. So, what happens when your program tries to load a settings file for a user, but it's their very first time running the app, so that file doesn't even exist yet? If you haven't planned for that, your program is just gonna fall over and crash.
And this is what that crash looks like. Python just throws up its hands and gives you this big, scary-looking file not found error. It's basically screaming at you, hey, I can't find the thing you asked for. And that just stops your program dead in its tracks. Not exactly a great experience for your users, right?
But don't worry, Python gives us this incredibly elegant way to handle it. It's called try except. Think of it like a safety net. You put the code that might fail, the risky stuff, inside the try block. It's like saying, Python, try to do this. Then you have an except block that's waiting to catch that specific error. If the file isn't found, instead of crashing, your program just jumps to the except block and runs that code instead. It's how you build robust, uncrashable apps. Okay, so your program can now remember things, it can handle errors. You are leveling up in a big way. But to build something really amazing, you're going to need more tools. You can't possibly be expected to write every single thing from absolute scratch. And that's what I like to call the lonely developer problem. I mean, trying to build everything by yourself is like trying to build a car by first going out and mining your own iron ore to make the steel. It's just wildly inefficient. The real power of being a developer today is that you get to stand on the shoulders of giants.
So, let me introduce you to your new best friend, Pipe, the package installer for Python. This little tool is your key, your gateway to a massive global library of code that other people have already written, tested, and shared. You need to download stuff from the web? There's a package for that. You need to make a cool graph? There's a package for that. You name it, it's probably out there.
And when I say massive, I'm not kidding. We're talking about more than 500,000 unique projects just sitting there waiting for you to use them for free. This is the collective brainpower of the entire global Python community, and it's all available to you right now. It is a staggering amount of power at your fingertips.
So, what's the catch? How do you get access to this universe of tools? Is it some super complicated process? Nope. It's one simple command you type into your terminal. Pip install, and then the name of the package. That's it.
With that one line, you completely solve the lonely developer problem. That whole library becomes part of your personal toolkit.
So, let's bring this all together. When you master handling files and you get comfortable with installing packages, you are fundamentally changing the game for yourself. You're not just writing little scripts anymore. You're now an architect, assembling powerful applications with a brand new developer toolkit.
So think about it. What are your new superpowers? Well, you can save user data, giving your app a memory. You can read config files, making your app flexible. You can handle errors like a pro, making your app stable and reliable. And, maybe most importantly, you can pull in powerful code from all over the world and finally stop reinventing the wheel. You now have the foundational tools that every single application developer uses every single day. That barrier that used to exist between your idea and a real, working program that actually remembers things, it's just been completely shattered. So, the only question left is, what are you going to build first?